So I'll quickly breeze through the initial slides. So we'll mostly be talking about retrofitting of building envelopes for energy efficiency from the point of view of how one should go about designing or looking at it from a retrofit point of view in the practicality of your practice. So, and towards the end, I'll try and share some cost-effective retrofit strategies, and then eventually we'll show you the what more can be done besides once the facade and the envelope is looked at carefully. How do you go about getting more savings from your energy efficiency measures? So our mission is delivering high performance complex buildings, lots of sectors, core services being MEP, and we are about 300 people firm. A big part of it is in India, almost 200 people, 150 or so, or 180 engineers, two centers in Mysuru and Delhi. Lots of collaborations getting back to the topic. So modern buildings are complex creatures. You need, whatever choices you're making for design or the system solutions that you might be thinking through need to look at affordability, environmental impact, whether it is feasible to construct and how fast can you construct, and what impact it will have. Is it replicable, and so on. So, what are the emerging technologies really, that you can focus on while looking at envelopes? So envelope being itself a system, how do you target? What are the considerations that you need to look at? What is the building orientation like? How much of what is the floor plate width? Is it an internally load dominated building, or is it a big fat building that will have limited impact of the outside, no matter what you do to the envelope? Is it passively cooled or actively cooled? How many floors does the building have? Does it really make sense to have roof insulation, for example, if it is a tall building? What is the window to wall ratio? How much the retrofit of the glazing can you look at? Some terrific examples from Vikas Ji earlier, who showed how he addressed the window areas there. And then eventually choosing the right materials. Cutting edge materials could be aerogel, could be anything. So what you see here is on the right is, this is a particular case where the building is thin on with the floor plate, and you are making certain choices related to the envelope and how much savings is it contributing. So this being a slightly tall building, there is so on the right, you have the savings as a percentage of the total energy. So that gray that you are seeing at the top is essentially the savings that you're getting from the various EEMs. So the roof insulation is hardly having any impact. Then can you do certain, wall insulation or wall material? What if the window to wall ratio? Can you impact that? Is there any high performance glazing that you're using? The max benefit that you are going to see in that thin, line that you see on the right is about 10% and not more. This is also very progressive. So just give me a second. I'm going to make sure that the ambient. Sorry. So coming back here, if the building, you need to look at the building performance. What is the building? Is it a big, wide floor plate where it will have little bearing or impact of the outdoors? So the envelope retrofits will have little impact. It could be, looking at the orientation, looking at in a thin building, what are the measures that you can deploy? These are a lot of things, the window itself, does it have a, daylight area that can contribute, that can help penetrate daylight deeper into the building beyond the work plane? Does it have shading devices and so on? So we'll cover some of that. So what are these strategies? One of the biggest strategies, and these are some of the schools that we have worked with. This particular school on the left is Mirambika in Delhi, and they have, this is a more than a retrofit. It is a adaptive reuse of a building. This building was actually a dormitory, and we literally broke down walls and opened up the school, opened up the walls. So the school classrooms don't even have walls, and it's a freely, the kind of, it's a small school, but the kind of free natural ventilation that you feel here is quite extraordinary. On similar ground, there is another school which was, there are many such schools which are coming all over in different parts of the country. This is Prakriti School. Again, you'd see the operable windows there. This is also looking onto the corridor, singly loaded corridor on the other side. So if the building is completely enclosed, then you need to start looking beyond thermal mass and natural ventilation. You will need insulation. How much of that insulation is really feasible in a retrofit project? Is it impactful? Is it, fast to construct? It needs to be affordable, so on and so forth. And likewise, glazing, is it affordable, effective, and fast to construct? And you'll need to put it to test through simulation and calibrate the model for the existing facility that you are, where you're trying to see whether this would be meaningful or not. So here you say this is a particular project where try to break down the window to wall ratio from that to this, and have shading devices as well. Whether a passive strategy for thermal comfort, variability, can we just simply open up the building? Can we start having jalis? These are again different projects where we have deployed venturi tubes and jalis, where it facilitates variability in thermal comfort and mitigates the harsh effects of the shading devices, like the previous presenter Vikas had mentioned. This actually has a BIPV, which is not visible in this picture. There is a solar photovoltaic. It gives a sort of a dappled light into the atrium below, and it also shades the atrium. And there are other projects where you have sort of a filigree of a light coming in through the facade. This particular building again is utilizing a different kind of natural ventilation. We broke open the windows in some cases, and in certain other cases we introduced jali, where it facilitated natural ventilation from the outside. And because it was a sort of a tall space with an atrium in the middle, this allowed the air to gently, keep rising as it picked up heat. This is the another project, not this particular one, but where we are using the same stack effect or displacement ventilation in an indoor environment. So this is, yeah, I mean, we test out these ideas in with computational fluid dynamics, with making sure that it is going to yield the results that we are expecting it to provide. The idea is to provide delightful, comfortable sensory experiences and make sure we utilize as much of the passive, features of the building that are there, and make sure that the retrofit strategies are productive and meaningful. Some of these case studies, not as good a picture, but something similar to the previous presenters. There are, you might see some of the spandrel edges being opaque. The actual visual part is those where you see external facades. This is a completely, outside insulation of a project for Vatica, which was later dry clad with certain spandrel portions also being opaque there. I hope my mouse is visible because I'm using it a lot. More and more of these, thin buildings, not very wide, where you could start introducing the outdoors to the indoor, to the inside, start making courtyards. Thin floor plates is a major, but that goes into the design aspect of it. But to be able to utilize that design later in your, this was the building that I was showing you for the stack effect, where we made sure that the architect didn't close off the building in these places. Otherwise, they would have had to start doing, some sort of a mitigation method or cooling, active method of cooling. A lot of shading for not creating atriums, but creating courtyards which are open to the sky, and making sure that you are minimizing as much as you can in terms of those features. Now, how do you make it more, future ready? Our mantra being high performance complex buildings, we try to then move forward with various simulation methods before we actually deploy these in the buildings. So this is a particular building where we are utilizing the displacement ventilation method that I was telling you about. This is a large retail store, technology giant that has a fruit with a bite taken out of it on its logo. This introduces the fresh air and the supply air, cool air at the bottom, and the idea is that the comfort is achieved. This thermostat, set point is achieved at the breathing zone. So we try and test out these things. There are many such stores which we are doing for the client. So in some of them, the outside being very inhospitable or tropical or humid, climate, then we tend to have features for the facade as well. We try and integrate various systems. This particular one is in India for one of the buildings I had shown earlier, Cycle Foundation, where the architect chose to have displacement ventilation within the space coupled with radiant cooling. And you can theoretically also tie up various systems, not just the radiant systems on the ceiling, but also, fresh air systems or displacement ventilation systems like that from bottom up. And but all the systems that we talked about need to be incorporated early in the base building design.